In this video, we're combining like terms. So like terms have the same variable and exponent, and the coefficients do not have to be the same. Now, as a reminder, terms are parts of a mathematical expression that are separated by addition and subtraction signs. So some like terms might be 5x and negative 4x. So I'm not looking at the coefficients 5 and negative 4. What I want to look at are the variables and the variable's exponents. So if the variable and its exponents are the exact same in both of the terms, then they are like terms. So another example would be y squared and 2y squared. Y squared has a coefficient of 1, even though it's not written, and 2y squared has a coefficient of 2, but that's not what makes them alike. What makes them alike is that the y and the exponent 2 matches this y and this exponent 2. Now, sometimes your like terms will have lots of different variables. You have to check and make sure that each individual variable and its exponent match and are exactly the same. So for example, a squared matches a squared, b squared matches b squared, and c matches c. Can't be an extra variable out here. There can't be different exponents on each of the variables. They have to be the exact same. So some examples of non-like terms: 5x and negative 4y. X and y are not the same variable. Y squared and 2x squared. Now we have the same exponents that are squared and squared, but y and x are different variables. They don't match. And then one that you got to be careful of is if you have lots of variables in each term, a squared does not match this a. So since it's missing a squared as its exponent, a squared, b squared, c, and a, b squared, and you can see c squared and c are different. These are non-like terms. So let's look at some examples of what we do when we have expressions with like terms. We've got a couple of steps here. Two very simple ones to start off with. First of all, you want to organize your like terms. And I like to do these little, I guess, call them swoops, or I don't know. You can call them what you like. But I'm going to look for variables that match m. So for example, I've got 7m, and then here's a 14m. Now, negative 6n does not match, negative 5n does not match, but 2m matches with the m. So I'm going to put those all together by organizing them, by writing 7m plus 14m, and now I'm going to bring the plus 2m, so all of the m's are combined together in one area that's the same. And then I've got this minus 6n and minus 5n. Now those are both like terms because they both have n, and n is their variables. So I'm going to write 6n minus 5n. Now, step 2 is to combine coefficients of like terms. This is very important. Pay attention to the plus and minus sign. So what I mean is, if you're not comfortable with integers, then you want to go through and rewrite minus signs as plus a negative 6n, plus a negative 5n. So you realize that if it's a minus sign in front of the term, it makes the term negative. All right, now I'm going to add the coefficients of like terms. So all of my m terms, I'm just going to add coefficients. So 7 plus 14 plus 2. 7 plus 14 is 21. 21 plus 2 is 23. The m is not going to change its exponent. It's still just m. I'm just adding the coefficients. Then I'm going to add negative 6n and negative 5n because they're like terms. The n, the variable's exponent, will not change. I'm just adding coefficients. So negative 6 plus negative 5 is negative 11. You could write this as plus negative 11, but I'm going to write this as minus 11 instead because that's how we will see it in algebra. And then add in that n at the end. And there is your simplified expression that came from this example. So one more time. I do not change the variable when I add the coefficients. I do not change the exponent when I add the coefficients. If it starts as an m, the final answer will be an m. If it starts as an n, the final answer will be an n. All right, let's look at a few more examples. So, number 2, I want to organize my like terms. Well, my like terms that I have, I've got 5h and h, 11g, and minus 8g. And again, if you want to write this as plus negative 8g, that's fine. But I'm going to rewrite it where I have 5h plus h together and plus 11g plus negative 8g together. And then part 2 is combine those coefficients of like terms. So 5h, and remember, if it's just h, that coefficient is 1, so 5 plus 1 would be 6h. And 11 minus 8 would be positive 3g. So there is my solution to number 2. All right. And then number 3, this one's getting a little bit more complicated. I've got a lot more terms. And you see I've got some exponents now. So I'm going to organize my like terms. I'm going to identify them first. So I've got just x's. So I've got a 5x, 8x. Now this is not like terms with the 5x and 8x because 10x has x squared. I do have a minus 4x. And again, this has an x squared. So we could say 10x squared and 7x squared are like terms. Again, if you want to rewrite this as plus negative, feel free to do that until you get comfortable with seeing that a minus sign makes the numbers negative. Now, let's rewrite this. 5x plus 8x, and then I've got plus negative 4x plus, and then my x squared is 10x squared plus negative 7x squared, and then add the coefficients of like terms. And add the coefficients of the x's. 5 plus 8 is 13. 13 plus negative 4 is 9, and those are my x's. And then add the coefficients of the x squareds. 10 plus negative 7 is 3x squared. And that is as far as I can simplify. So that is my solution.